All right, so let's look at this next section. This is the yellow section of your rainbow review. So first off, it says, what is a reference angle for 4 pi over 3 radians? Well, if you need a visual, 4 pi over 3 radians, well, if we were to remember that pi is right here, so that's halfway. So if we were to break that up into 3 sections, we would have, or we can even go all the way around the unit circle and break the entire unit circle up into thirds. Well, 4 pi over 3 would be down here. Okay, so that's going to be right there. Well, the reference angle would be the angle in quadrant 1 that would match up, that would coincide with that angle. And that would be this one here, so that would be at pi over 3. So our answer for that would just be pi over 3. So the reference angle is going to be the angle in the first quadrant. So it says in this next part, trace the 4 pi over 3 radians and its reference angle on the unit circle. So this would be 4 pi over 3 down here in this corner. And this would be its reference angle. So that would be that. And remember so this will help us to answer the next question. At pi over 3, this is where your answer would be 1/2, and your sine would be square root of 3 over 2. Remember down here that everything's the same, except for everything's negative. So it would be negative 1/2 and negative square root of 3 over 2. So now when it says find the sine of 4 pi over 3, well, that we just said would be negative 1/2. I'm sorry, sine, not cosine. So it would be negative square root of 3 over 2. The cosine of 4 pi over 3, that would be negative 1/2. And the tangent, well, that we have to do a little bit of work. Remember, the tangent is the same as the sine of theta over the cosine of theta. Well, the sine, we said that's negative square root of 3 over 2. And the cosine is negative 1/2. So to simplify this, we're going to multiply the top and bottom by the conjugate of the denominator. So these would cancel out up here in the numerator. The 2's would cancel out, so we left with square root of 3 over 1, which is just the square root of 3. So that would be your answer for that one. Let's go ahead and do the green section as well in the same video. All right, so the sine function. So this one here is, so the sine function, where again its period here would be 2 pi in radians, and it would have an x-intercept there at pi. It would go from 1 to negative 1, so this will be helpful. Remember, it repeats itself over and over again, but this would be one period of the sine function. So the period would be 2 pi radians. The frequency is the reciprocal of that, so it would be 1 over 2 pi, because it occurs once every 2 pi radians. Now the midline is referring to this line right here, which you could say the x-axis, but it's better to refer to it as a line, so that would be the line y equals 0, because it intersects the line where y is 0. The amplitude is how far above and below the line it fluctuates. So it goes 1 unit above and 1 unit below, so we'd say the amplitude would be 1. The domain is the fact that it goes from negative infinity to infinity. The range, again, it fluctuates between negative 1 and 1, and those points are included, so we would use brackets for those. Then for number 2, it says, which of the above key features are the same for the cosine function? So let's look at the graph of the cosine function. So the cosine function, one period would look like this. So what's the same? Well, the period is still 2 pi, so that's the same. The frequency then is the same. That's going to be 1 over 2 pi. The midline is in the same place, so that would be the same. The amplitude is the same. The domain is the same. And the range is the same. So other than the shape of the graph, everything is the same between those two functions. All right, so then it says in number 3, it says list the key features in the function. So by key features, we mean things like the amplitude, the period, the phase shift, and the vertical shift. And so for this one, remember this value here gives you the amplitude. So we know the amplitude would be 3. The period we get from this. Okay, so we take the reciprocal of that value. Because remember, whatever happens to the x, we always do the opposite. So we're multiplying. The opposite in this case would look at the reciprocal. So reciprocal of 2 is 1/2. So that means horizontally it's being shrunk to be 1/2 the size. And normally the period would be 2 pi. So half of 2 pi would be pi. So our period would be pi here. And there is no phase shift and there's no vertical shift. So the phase shift would be 0, the vertical shift would be 0. which brings us to number 4, the last one in this green section. So here, for this one, it asks for a possible sine function and a cosine equation, or both a sine and a cosine equation for both of these, or that would give us this one graph. So there's actually 3 different equations we could come up with, and I'll come up with all 3 of them for you. So let's first identify what the amplitude is. So here would be that horizontal line, and I could see the distance between that horizontal line and the maximum value there is actually 2 units. Okay, so this would be 2 units. So the amplitude is 2. The period, we see that, let's just pick a point, it doesn't matter which one it is, let's say this one, that repeats itself here. So we got to figure out what's that distance. Okay, that distance is 4 pi radians. Okay, it's always easier if you start at 0, because we could just see that here it starts at 0, ends at 4 pi, so it's a distance of 4 pi. But if we found the distance between these 2 points, between negative 2 pi and 2 pi, that's also 4 pi radians. So every point repeats itself every 4 pi radians. Okay, so that's the period. Now, if we're going to deal with the sine function, let's start with that one. Because the phase shift is going to be different depending on which graph we look at. So the sine function, remember, typically would have started here, and then it would go up and then down and look like that. So this point, let's just focus on that. That starting point is now right here. So this is at pi. So here is, let me highlight that instead. Here is my sine function. Okay, so let's move to the right pi units. So we would say that the phase shift, so the phase shift would be pi. The vertical shift, it's not going up or down. So now we can come up with an equation for the sine function. So it would be y equals, so the amplitude would be 2, times the sine. Now here it's going to the right pi units, so it would be x minus pi. And the period is 4 pi, so that means that it's being stretched by 2. Okay, so it's stretched by twice the size. So when we go to the equation, we do the reciprocal. The reciprocal of 2 would be 1/2. So we're going to put that 2 down there in the denominator. So if you were to check this graph on Desmos, you would see that these, or on your graphing calculator, you would see that those are the same. Okay, so this would be your answer using the sine function. Let's look at the cosine function. So for the cosine, the phase shift is different. Okay, the cosine function, the graph would have started, well, we would stretch it up here, so let's just look at that. So the graph would start here and would have came down and look like that. So that starting point has been moved 2 pi radians to the right. So the phase shift would be 2 pi. And the vertical shift, again, it's not going up or down at all. So for this one, your cosine function, again, we have an amplitude of 2 times the cosine. And then we're moving it to the right 2 pi radians, so it would be x minus 2 pi. And then, again, it's being stretched to be twice the size, so it would be divided by 2. Now you could also look at it as maybe being moved to the left 2 pi. And so maybe you had x plus 2 pi here. And that would also work. Okay, so moving it to the left 2 pi or to the right 2 pi, it would be the same thing. And there's one other equation. Did you get that one? Did you get the other equation? Maybe you notice that this has been flipped over the x-axis. Remember, what would cause it to do that would be if we have a negative amplitude. So if we put a negative 2 there, it would cause a graph to be flipped. So instead of being up at the top, because the cosine function, remember, would look something like that, well, the negative would cause it to flip. So that point would be down here. So then we could just say negative 2 times the cosine, and if that's the case, it would have no phase shift. So we would just say that it's x divided by 2. So you could use either one of these 2 equations for the cosine function, and then the purple would be the sine function. So that's how you do the gold and the green sections here. So hopefully that answers your questions.